What was the first thing you did when you woke up this morning? Maybe you hit the alarm on your phone. You probably flicked on the light, turned on the radio or TV. Did you use a microwave? In fact, everything you've done today probably relies on this. Tungsten. In just about every corner of our modern lives, tungsten makes a difference.
So tungsten's used in an awful lot of applications,
such as electronics,
your phone, your laptop,
medicine,
light bulbs.
It's a huge range of things.
And tungsten's just one of the critical metals that make much of modern life possible.
Niobium, tantalum, indium.
There's a lot of material of all sorts in the crust under our feet.
Tellurium, gallium, selenium.
So much, everything you really do in modern life relies on electronics, which relies on these critical metals.
I'm Evie. I'm a geologist at the British Geological Survey, and this is the story of what critical metals do for us. If you've ever been anywhere quiet, where you needed to take a call or text, then this little vibrate would have been incredibly useful to you. Inside this phone, there is a tiny piece of metal that's one of a number often known as critical metals, tungsten. Tungsten is heavy for its size and strong. You only need a tiny amount to make a phone vibrate. And that's only one small use for this incredibly versatile metal.
Tungsten is used in a number of different applications. Many of them are industrial applications.
It's really hard, it has a very high melting point, and it's used in a lot of alloys, so things like jet engines, big turbines in power generation.
And it's also used in a number of high specification alloys, and it's also used, maybe as a few domestic examples, it's used in light bulb filaments, and it's used in many electronic devices.
And if it's not actually in something, then it's probably helped make it. From the DIY enthusiast to the type of kit used to extract raw material from deep underground, saws and drills owe their teeth to tungsten. And alongside tungsten sit the other so-called critical metals.
Generally metals that have a high economic importance and are also liable to supply shortage.
Be that geological, be that kind of economic, maybe there's not many producers.
They generally don't have substitutes.
And these minerals might have niche applications, but very important applications.
They often have a very low recycling rate.
Take away critical minerals, you pretty much have to live without everything you've become accustomed to in Western society. So your phone, your car, large parts of sort of power supply to your house, pretty much all your electronic goods really. So your laptop, internet connection, all that.
So we need them for just about everything we do. And that means we need to make sure we can get them. But this presents some problems. They're not called critical metals for nothing.
If you have a supply shortage of these metals, then that in turn can have an economic impact on society in terms of limiting manufactured output or limiting the availability of certain products.
These are the buried treasures under our feet. Across the world, there are enough supplies of all critical metals to last hundreds of years. But the Earth doesn't give up its treasure easily.
Many factors can interfere with the supply of critical metals. The location of these are really quite restricted in some cases. You know, that currently you might only get some of these materials from 1 or 2 mines around the world, and if that mine closed, or perhaps that country decided to stop exporting, that would really restrict our supply. What
we need to do to try and avoid that sort of situation is that we need to diversify our supply base.
And there's economic things as well. These can be quite expensive to extract.
It's going to be important to improve efficiency of usage. So not using these metals in applications that are maybe not so critical, or you know, maybe learning to use less.
And in a lot of cases as well, these aren't the primary metals that are extracted. These things are byproducts.
It's going to be important to improve recycling of some of these metals.
This is a big planet we live on, and there's a lot of material of all sorts in the crust under our feet. I think, you know, we need to be sure we've got a steady supply of them coming on stream. We need to make sure we're looking for these minerals, we're developing mines so we can dig them out of the ground, developing processes we can use to extract them from ores. You know, so we need to make sure we've got that steady supply, but you know, I think there's plenty in the ground.
But mines can take years to come on stream. Future supplies rely on action now, and here at the British Geological Survey we're playing our part.
The BGS is trying to raise awareness of the issues surrounding critical metals.
Looking at how they're formed and where they're formed.
How much is used, how much is recycled.
To see if we can extract these sorts of metals from things that are normally considered as waste, like fly ash or material from landfill.
And here, in this laboratory, we're trying to understand how deposits of these metals are formed. This technology allows us to identify the geological fingerprints of critical metals so that we can focus exploration at the right places.
You know, we need to make sure that we use the best mineral for the best job. And for that, we need to really, you know, make sure we keep these steady supplies of these minerals.
I'd like to see us convey that to a broader audience so that people in general, the public, better understand these issues.
And there's already good news when it comes to tungsten.
In Britain, actually, in Devon, we're developing what will be the Western world's biggest tungsten mine.
A large proportion of global production of tungsten is based in China.
We need to kind of think about these projects and make sure we have these projects on stream to deliver the metals we need.
We need to diversify our supply base, which basically means that we need to try and source tungsten from somewhere else other than China.
Because, you know, in Europe we do have these materials, and you know, we need to think about how we can develop them, how we can use them to kind of, you know, develop ourselves and our industries.
You know, this isn't just fun for me. It wakes me, it connects me, it keeps me informed. Like millions of others, I don't know what to do without it. At BGS, we're working to make sure I don't have to.
Without critical metals, I wouldn't have my music collection, be it on CD or on my iPod.
I suppose really my car would be the big one. I wouldn't be able to get around. I wouldn't be able to get around and do the things I love. But then, you know, some people might be their phone, their laptop, the internet connection. You know, so many things rely on these.
I would hope that in 10 years' time we would have a much better understanding of the critical metals.
You can mine sustainably.
It's quite an abstract sort of linkage between something in the ground and something that you can't live your life without. And I think a lot of people don't make that connection. And I think that's part of our responsibility, to make people aware of that connection.